Now imagine this. If you drove to the moon right now at 130 kilometers per hour without ever stopping or slowing down, you would spend 4 straight months on a dark, endless road before finally touching the moon, sitting 384,000 kilometers away. But if you pointed your car toward the sun at that same speed and started driving from the day you were born, you'd still need around 130 years of non-stop driving to arrive. And the terrifying part? In the scale of the universe, that distance doesn't even count as leaving home. Take the sun, for example. It's so massive that about 1.3 million Earths could fit inside it. But among stars, the sun instantly becomes just a slightly brighter spark. Arcturus is about 25 times wider than the sun. Via Canis Majoris is roughly 45 times wider. Stephenson 2-18 is around 78 times wider. And if these giants replaced our sun, some of them would swallow the orbits of Mercury, Venus, and even Earth itself. Then comes UY Scuti. If placed at the center of our solar system, it could stretch so far that even Jupiter, sitting 778 million kilometers away, might end up inside the star. And somehow, even stars this enormous are still tiny when compared to the scale of the entire universe. And even then, it would still be nothing more than a tiny dot. That's what truly crushes the human mind. Not just how big these objects are, but the unimaginable distances between them. At this scale, cars, airplanes, and even rockets become meaningless. Human speeds are simply too slow. That's why we measure the universe with light itself. The farthest object humanity has ever sent is the spacecraft Voyager 1. Launched in 1977, it has been traveling for nearly half a century at around 62,000 kilometers per hour, about 160 times faster than a Formula One race car. Sounds insanely fast. But after 49 years, it has only traveled about 25 billion kilometers, not even a full light day away. According to NASA, around February 2027, Voyager 1 will finally complete the distance of 1 light day. And if we calculate using the solar system's much larger gravitational boundary, Voyager 1 still hasn't truly left the solar system at all. It may need another 2,500 years just to begin entering the enormous frozen cloud of debris surrounding our solar system. Then it would still need roughly 25,000 more years to pass through that region and finally escape the sun's gravitational influence completely. And even after all that time, the distance Voyager 1 would have traveled would still equal only about 1/4 of the distance to the nearest star, Proxima Centauri. Proxima Centauri is 4.2 light-years away. That sounds close. But one of the universe's greatest illusions is making the word nearest feel actually near. If Voyager 1 were flying directly toward Proxima Centauri, it would still need around 100,000 years to arrive. And what does 100,000 years even mean? Human civilization, from the beginning of agriculture until today, is only a little over 10,000 years old. By the time Voyager 1 reached the nearest star, nobody knows whether today's countries, or even humanity itself, would still exist. Now imagine it from another perspective. A single photon has just left the surface of the sun. It travels at the fastest speed in the universe. In just over 3 minutes, it reaches Mercury's orbit. 6 minutes later, it arrives at Venus. At 8 minutes and 20 seconds, it crosses Earth's orbit. At 12 minutes and 30 seconds, it reaches Mars. Then it still needs another half hour just to arrive at Jupiter. After 1 hour and 20 minutes, it passes Saturn. And after 2 hours and 40 minutes, the photon reaches Uranus. Nearly 2 more hours later, it finally rushes past Neptune and enters the Kuiper Belt. At this point, you might think the solar system is almost over, not even close. The photon still has to travel for hours through this frozen disk of debris, then continue across weeks of darkness before reaching the inner edge of an even more distant region. And after that, it must keep flying at the speed of light for nearly an entire year to cross the enormous Oort cloud, the true outer boundary of the solar system. And remember, light is the fastest thing in the universe. Yet even after leaving the solar system, that same beam of light still needs more than 3 additional years to finally reach Proxima Centauri. That is the universe's first layer of cruelty. It doesn't trap you behind walls. It simply stretches distance to a scale that breaks the human mind. And once distances become large enough, even light begins to fade away. Take Proxima Centauri. The star itself is already dim, and by the time its light reaches Earth, the human eye cannot see it at all. Humanity didn't discover it until 1915 using telescopes, and in cosmic terms, that's still only our front yard. If an observer stood 50 light-years away with eyes similar to ours, they might not even be able to see our sun. The sun, we depend on for every second of life at a distance of 50 light-years, becomes so faint that it can disappear into the cosmic background itself. On a clear night from Earth, the human eye can see roughly 6,000 stars, but almost all of them are packed inside a tiny local bubble of the Milky Way. When you look up at the night sky, it feels like you're seeing the entire galaxy, but in reality, you're only seeing a small cluster of nearby lights. The Milky Way is about 100,000 light-years wide and roughly 1,500 light-years thick. Inside it may exist hundreds of billions of stars, and every beautiful, full image of the Milky Way you've ever seen online is not a real photograph taken from outside the galaxy. Humanity has never left it. We are trapped inside the Milky Way like an ant standing somewhere inside Beijing, trying to draw a complete map of China. If we wanted to travel outside the galaxy and take a real photo of its full shape, then at the speed of Voyager 1, the journey would take about 550 million years. And 550 million years ago, Earth had not even fully developed complex, large animal life yet. At that point, this is no longer just far away. Distance has become so enormous that it crushes time itself. And if we shrink the scale down just a little, the picture becomes even more terrifyingly clear. Now imagine shrinking everything in the Milky Way by 70 billion times. At that scale, the sun would be only 2 centimeters wide, small enough to sit in your hand. The Earth would shrink to the size of a needle tip, orbiting just 2 meters away. Jupiter would look like a tiny lentil 8 meters out. Neptune would be a grain sitting 67 meters away. Voyager 1 would be almost invisible, a dust-like speck floating 280 meters from the sun. And yet, even with the sun reduced to a tiny 2-centimeter ball in your hand, the nearest star, Proxima Centauri, would still be 580 kilometers away. If you were standing in Beijing, that star would already be somewhere in another province. And the center of the Milky Way, it would still sit 3.7 million kilometers away, nearly 10 times farther than the real moon is from Earth. That is just our galaxy. And the Milky Way is not the universe. Only about 150 years ago, humanity still thought the Milky Way might be the entire universe. Then our telescopes shattered that illusion. In 2003, astronomers pointed the Hubble Space Telescope toward an incredibly tiny, dark patch of sky. How tiny. Imagine stretching out your arm and holding up a needle. The region Hubble observed was about the size of the tip of that needle against the sky. The Hubble Space Telescope stared at that tiny patch of darkness for about 1 million seconds, and when the final image came back, a few bright points were nearby foreground stars, but almost everything else in the picture was not stars at all. They were galaxies. In that unbelievably tiny piece of sky, humanity counted roughly 10,000 galaxies, and to cover the entire sky with images of the same size, we would need around 23 million photographs. That's why scientists now estimate that the observable universe may contain around 2 trillion galaxies. Inside that number, the Milky Way doesn't even qualify as a city. It's more like a glowing grain of dust floating in an endless dark ocean. The nearest large galaxy to us is the Andromeda galaxy. If it were bright enough for human eyes to fully see, it would appear in our night sky as a gigantic glowing shape far larger than the full moon, and yet it is still 2.5 million light-years away. The light from Andromeda that reaches your eyes tonight began its journey 2.5 million years ago. At that time, modern humans did not even exist yet. More ancient members of the human lineage were still walking across Africa, so when you look at Andromeda, you are literally seeing light from before humanity was born. And incredibly, Andromeda is still considered our neighboring galaxy. If Voyager 1 tried to fly all the way to the Andromeda galaxy, the journey would take roughly 56 billion years. That is several times longer than the current age of the universe itself. That's the terrifying truth of cosmic neighbors in the universe. They are neighbors you can never truly reach. Our Milky Way and Andromeda, along with dozens of smaller galaxies, form what astronomers call the local group. Beyond that are even larger galaxy clusters, then superclusters, stretching farther and farther into the deep universe. These galaxies spread across space like bubbles, filaments, and giant cosmic webs. From a large enough scale, the universe no longer looks like scattered stars. It looks like a glowing spiderweb. Every bright node may contain entire galaxies. Every thread may hold countless stars and planets. And all of this is still only the observable universe. The so-called observable universe is simply the portion of space whose light has had enough time to reach us. Its boundary lies more than 45 billion light-years away. But what exists beyond that edge? Possibly more galaxies, more superclusters, more regions of space humanity will never see. And perhaps the universe doesn't even have an edge at all. Maybe it isn't merely big. Maybe it is infinite. And maybe the universe doesn't expand toward an ending at all. Maybe it simply never stops. Now let's make the comparison even more brutal. Imagine the sun is reduced to a tiny 2-centimeter sphere printed on the cover of a book. Each book has 250 pages. Mercury appears on page 4. Venus is on page 8. Earth sits on page 10. Mars is on page 16. Jupiter reaches page 55. Saturn appears on page 100. Uranus is on page 200. Neptune has already moved into the second book, around page 75. Voyager 1 drifts near the beginning of the 7th book. The true outer boundary of the solar system would not appear until around book number 3600, and the nearest star, Proxima Centauri, would sit somewhere near book 11,000. Now imagine printing the distance to the Andromeda galaxy into the same scale. You would need about 6.5 billion books. Stacking those books would require a space roughly 300 times larger than the world's biggest library. And if you wanted to print all the way to the edge of the observable universe, you would need buildings 12 stories tall, covering an area the size of France. Every floor packed completely with books, and almost every page would still be black, because most of the universe is empty. Occasionally, there would be a tiny dot of ink. That dot would be a star. That dot would be an entire galaxy. And that is the universe we call crowded. Hearing all this, you might start to feel that humanity is unbelievably small, almost laughably small. But the cruelest part of the universe is this: it doesn't only crush you with what is enormous, it also crushes you with what is tiny. Compared to a single water molecule, you are proportionally larger than the sun is compared to you. And if we keep descending deeper into the microscopic world, from atoms to protons, and from protons toward the mysterious Planck length, the gap in scale becomes almost as absurd as the gap between a human and the entire Milky Way. In some ways, humanity may actually be closer in scale to the observable universe than to the true smallest possible scale of reality. And that is the part that truly unsettles the mind. Human beings exist trapped in the middle. Above us, galaxies, cosmic webs, the observable universe, and perhaps infinite space beyond. Below us, atoms, protons, quantum fields, and depths of reality we may never fully reach. We stand on a tiny rock floating through darkness, using 2 fragile eyes to look at a few thousand stars. And then we start believing we've seen the universe. But the truth is, we never actually have. We are not seeing the universe itself. We are standing in total darkness, collecting a few ancient beams of light that left their sources millions or billions of years ago, and then stitching them together into something our brains can barely hold. A world too vast for imagination, built from the smallest possible samples. So the next time you look up at the night sky, don't rush into romance. What you're seeing is not the full face of the universe. It's just a tiny patch at the doorway, a faint hint of light that happened to arrive at exactly the right moment. And that's it. I'm Lao Ma. See you in the next universe.